or countable number of values, it's called a discrete random variable. Example, the number of heads obtained when 2 coins are tossed is a discrete random variable, as x assumes the values of 0, 1 or 2, which form a countable set. The number of aces when 10 cards are drawn from a well-shuffled pack of 52 cards. Find k. In a random variable x, probability mass function is summation of x is equal to 0 up to 0, p of capital X is equal to small x is equal to 1, x is equal to 0, 49k is equal to 1, that is, k is equal to 1 by 49. P of x lesser than 4 is equal to p of x is equal to 0 plus p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 is equal to 1 by 49 plus 3 by 49 plus 5 by 49 plus 7 by 49 is equal to 16 by 49. P of x greater than or equal to 5 is equal to p of x is equal to 5 plus p of x is equal to 6 is equal to 11 by 49 plus 30 by 49 is equal to 24 by 49. P of 3 lesser than x lesser than or equal to 6 the whole is equal to p of x equal to 4 plus p of x is equal to 5 plus p of x is equal to 6 is equal to 33 by 49. The minimum value of x is determined by trial and error method. P of x lesser than or equal to 0 is equal to 1 by 49 lesser than 1 by 2. P of x than 1 is equal to 4 by 49 lesser than 1 by 2. Proceed as above till we get the smallest value of x, for which p of capital X lesser than or equal to small x greater than 1 by 2 is 4. Continuous random variable. A random variable x is said to be continuous if it can take all possible values between certain given limits. That is, x is said to be continuous if its values cannot be put in 1, minus 1 correspondence with n, the set of natural numbers. Example, the life length in hours of a certain light bulb. Probability density function, PDF. The mathematical definition of continuous probability function f of x is a function that satisfies the following properties. 1. Probability that x is between 2 points a and b is p of a lesser than or equal to x lesser than or equal to b, the whole is equal to integral a to b f of x dx. 2. Is non-negative for all real x. 3. The integral of the probability function is 1. Cumulative distributive function. If x is a continuous random variable function given as shown above, where f of t is the value of the probability density function of x at t, is called the distribution function of cumulative distribution of x. Properties of distribution function are shown above. The above example, to find k, since f of x is a probability density function. Integral minus infinity to x, f of x dx is equal to 1. Therefore, integral 0 to 1, k of 1 minus x squared the whole into dx is equal to 1. Integrating and then applying limit, we get k is equal to 3 by 2. A. When x belongs to minus infinity, 0, b. When x belongs to 0, 1, f of x is equal to integral minus infinity to x, f of t dt. Mathematical expectation. Expectation of a discrete random variable. If x denotes a discrete random variable which can assume values x1, x2 up to xn with respective probabilities p1, p2 up to pn, then the mathematical expectation of x denoted by E of x is defined as shown. Thus, E of x is the weighted arithmetic mean of the values x1 with weights as shown. Hence, mathematical expectation E of x of a random variable is simply the arithmetic mean. Moments. Expected value of a function of a random variable x is used for calculating the moments. We will discuss about two types of moments. 1. Moments about the origin. 2. Moments about the mean, which are called central moments. Let x be the random variable denoting number of trials to get a first success. Success in the second trial means failure in the first trial. Probability of success in the third trial is q squared p. As it goes on, the success may occur in the nth trial, which means n minus 1 trials are failures. Therefore, probability is equal to q power n minus 1 p. From the table, f of x is equal to p into minus q, the whole to the power of minus 2 is equal to p of p to the power of minus 2 is equal to p by p squared is equal to 1 by p. Apply the formula mean as shown. Applying limits 0 to 2, we get mean is equal to 1. E of x the whole squared is equal to integral minus infinity to infinity x squared f of x dx is equal to integral 0 to x squared 3 by 4 x of 2 minus x the whole dx is equal to 3 by 4 integral 0 to of 2 x to the power of 3 minus x to the power of 4 dx. Integrating limit 0 to 2, we have e of x the whole squared is equal to 6 by 5. Variance is equal to e of x the whole squared equal to e of x the whole squared is equal to 6 by 5 minus 1 is equal to 1 by 5. Theoretical distributions. The values of random variables may be distributed according to some definite probability law, which can be expressed mathematically, and the corresponding probability distribution is called theoretical distribution. Theoretical distributions are based on expectations on the basis of previous experience. In this session, we shall study 1. Binomial distribution, 2. Poisson distribution, 3. Normal distribution, which figure most prominently in statistical theory and in application. The first two distributions are discrete probability distributions, and the third is continuous probability distribution. Probability function of binomial distribution. Let n be given positive integer and p be a given real number, such that 0 less than or equal to p less than or equal to 1. Also, let q is equal to 1 minus p. Consider the finite probability distribution described by the following table. The table shown above is called the binomial distribution. The second row of the table are the successive terms, the binomial expansion of q plus p the whole to the power of n. Binomial probability function b of n comma p comma x gives the probability of exactly x successes in Bernoullian trials, p being the probability of success in a trial. The constants in it p are called the parameters of the distribution. We know that standard deviation 2 by root 3, mean np is equal to 2, root of npq is equal to 2 by root 3. Squaring, we get npq is equal to 4 by 3, gives q is equal to npq by np is equal to 4 by 3 by 2 is equal to 4 by 6 is equal to 2 by 3. But success plus failures is equal to 1. P plus q is equal to 1. P is equal to 1 minus q is equal to 1 minus 2 by 3 is equal to 1 by 3. And p is equal to 2. N of 1 by 3 is equal to 2 cross multiply n is equal to 6. The probability function for distribution is obtained as shown, where x is equal to 0, 1, 2 up to 6. A doublet can be obtained when a pair of dice thrown is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, that is 6 ways. P plus q is equal to 1. P is equal to 6 by 36 is equal to 1 by 6. Q is equal to 1 minus P is equal to 1 minus 1 by 6 is equal to 5 by 6. Let x be the number of successes. We have P of capital X is equal to small x is equal to cx p power x q power n minus x. P of 4 successes is equal to P of x is equal to 4 is equal to 35 by 216 of 5 by 6 to the power 6. P of no success is equal to P of x is equal to 0 or 5 by 6 to the power of 10. Poisson distribution. Poisson distribution is limiting case of binomial distribution under the following conditions. A. N, the number of trials, is indefinitely large, that is, n up to infinity. B. P, the constant probability of success in each trial, is very small, that is, P up to 0. C. NP is equal to lambda is finite, where lambda is a positive real number. When an event occurs rarely, the distribution of such an event may be assumed to follow a Poisson distribution. Definition: a random variable x is said to have a Poisson distribution if the probability mass function of x is P of capital X is equal to small x is, as shown above, for some lambda greater than 0. The mean of the Poisson distribution is lambda and variance is also lambda. The parameter of the Poisson distribution is lambda. In a Poisson distribution, if P of x is equal to P of x is equal to 3, find P of x is equal to 5. Given e power minus 3 is equal to minus 0.050. A problem P of x equal to is equal to P of x is equal to 3. E power minus lambda into lambda squared by 2 is equal to e power minus lambda into lambda to the power of 3 by 3. On simplifying, we get 3 lambda squared is equal to lambda to the power of 3. Solving, we get as lambda is equal to 0, lambda is equal to 3. Using Poisson distribution formula to trial, P of x is equal to 5 is equal to 0.101.
Find the probability distribution of the number of sixes in the throwing of 3 dice 1. Two cards are drawn successively without replacement from a well-shuffled pack of 52 cards. Find the probability distribution of the number of queens. A discrete random variable x has the following probability distribution. Find the value of a. Find p of x is lesser than 3. Find p of 3 is greater than x greater than 7. Verify that the following are the probability density functions. F of x is equal to 2x by 9. 0 is lesser than or equal to x, lesser than or equal to e, 0 elsewhere. F of x is equal to 1 by pi into 1 by 1 plus x square, comma, minus infinity is lesser than x, lesser than infinity. Find the probability density function f of x is equal to ex in 1 minus x the whole cube. 0 is lesser than x, lesser than 1, 0 elsewhere. Find the constant c. The probability density function of a random variable x is f of x is equal to kx to alpha minus 1 e raised to minus 1 beta x alpha. X alpha beta is greater than 0, 0 elsewhere. Find k. P into x is greater than 10 is equal to integral 10 raised to infinity f of x into dx. A continuous random variable x has the PDF defined by f of x is equal to c e raised to minus ax. 0 is lesser than x, lesser than infinity. 0 elsewhere. Find the value of c if a is greater than 0. A random variable x has a probability density function f of x is equal to k. 0 is lesser than x, lesser than 2 pi. 0 elsewhere find k. P into 0 is less than x, less than pi by 2 is equal to integral 0 raised to pi by 2 k into dx. A die is tossed twice. A success is getting an odd number on toss. Find the mean and variance of the probability distribution of the number of successes. Find the expected value of the number on a die when thrown. In a gambling game, a man wins rupees 10. If he gets all heads on all tails and loses rupees 5, if he gets 1 or 2 heads when 3 coins are tossed once, find his expectation of gain. The probability distribution of a random variable x is as given below. If y equals x square plus 2x, find the mean and variance of y. Find the mean and variance for the following probability density function of f of x is equal to 1 by 24 minus 12 is lesser than or equal to x lesser than or equal to 12. 0 elsewhere 0. The mean of a binomial distribution is b and its standard deviation is 3. Is this statement true or false? Comment on it. If on an average, one ship out of arrives safely to port, find the mean and the standard deviation of the ships returning safely out of a total number of 500 ships. The overall percentage of passes in a certain examination is 80. If 6 candidates appear in the examination, what is the probability that at least 5 pass the examination? Let x have Poisson distribution with near 4. Find p into x is lesser than or equal to 3. P into 2 is lesser than or equal to x less than or equal to 5. E raised to minus 4 is equal to 0.0183. Air particles are emitted by a radioactive source at an average rate of 5 in a 20 minutes interval. Using Poisson distribution, find the probability that there will be 2 emissions. at least 2 emissions in a particular 20 minutes interval. The number of accidents in a year involving 60 drivers in a city follow a Poisson distribution with a mean equal to 3. Out of 1000 taxi drivers, find approximately the number of drivers with no accidents in a year, more than 3 accidents in a year. If x is a normal variate with mean 80 and standard deviation 10, compute the following probabilities by standardizing. P into x is lesser than or equal to 100. P into x is lesser than or equal to 80. P into 65 is lesser than or equal to x less than or equal to 100. If z is a standard normal variate, find value c for the following. P into 0 is less than z less than c, that is equal to 0.25, and P into minus c is less than z less than c, that is equal to 0.40. The life of army shoes is normally distributed with a mean of 8 months and a standard deviation of 2 months. If 5,000 pairs are issued, how many pairs would be expected to need the replacement after 12 months? If the height of 300 students are normally distributed with a mean 64.5 inches and a standard deviation 3.3 inches, find the height below which 99% of the students die.